Geometric sequence and series. Geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant called common ratio, denoted by small letter r. For an instance, if we have a geometric sequence 3, 12, 48, 192, and so on. Our first number is 3. Our second number is 12, which is also equal to 3 times 4. Our third number is 48, which is also equal to 3 times 4 squared. And the fourth number, 192, which is also equal to 3 times 4 cubed. So our 3 here is our a sub 1. This would be a sub 2, a sub 3, a sub 4, and so on. So as you have noticed, our a sub 1 is equal to 3, wherein our a sub 2 is equal to 3 times 4, because our exponent here would be n minus 1. So if we use 2, that would be 2 minus 1, which is equal to 1. And for this case, this is a sub 3. This would be 3 minus 1. So that becomes 2. And for our a sub 4, we have here 4 minus 1. It becomes 3. So in that case, we can get the formula in finding the n term of a geometric sequence, which is a sub n is equal to a sub 1 times r raised to n minus 1. Wherein our a sub n is our n term, or the last term. Our a sub 1 is the first term. Our r is the common ratio. And our n is the number of terms, or the term number. So let us have other examples. Let us take 8, 16, 32, and so on. So this one is considered as a geometric sequence, because the common ratio here would be 16 over 8, which is equal to 2. So as we do that, you have 8 times 2 is equal to 16. 16 times 2 is equal to 32. Another example. If we have 10, 5, 5 over 2, and so on, this one is also considered as geometric sequence. Why? Our ratio would be 5 over 10, or 1/2. To get the next terms of the given sequence, we multiply this r 1/2 to the first term and to the other terms. Therefore, we have 10 times 1/2 is 5, and 5 times 1/2 is equal to 5 over 2. Another one. we have 1/2, 1/4, 1/8, 1/16, and so on. Our R is equal to 1/4 over 1/2. We have here a complex fractions. To solve this, we take the reciprocal of the denominator and then we multiply. Therefore, we have 1/4 times 2 over 1. And that would be equal to 1/2. Getting the next terms, we have 1/2 times 1/2 is equal to 1/4. Again, if we're going to multiply fractions, we multiply the numerator to the numerator. So this is the numerator. This one is also a numerator. So 1 times 1 is 1. Then 2 times 2 is 4. Doing the same process for the next terms, we have 1/4 times 1/2 is 1/8. 1/8 times 1/2 is 1/16. So now, let us solve problems involving geometric sequence. If the third term is 2/3 and the eighth term is 1/48, find a sub 1, r, and the 10th term. So we have to find for a sub 1, our common ratio, and the 10th term. So again, our given, we have a sub 3 is equal to 2/3, and our a sub 8 is equal to 1/48. So taking our a sub 3, that would be a sub 3 is equal to a sub 1 times r squared. So this one was taken from the formula a sub n is equal to a sub 1 times r raised to n minus 1. So we have here 3. So we substitute here. So that becomes 3 minus 1 is equal to 2. So we have here a value of a sub 3, which is 2/3. So we substitute. 2/3 is equal to a sub 1 times r squared. Let's do this with a sub 8. So we have a sub 8 is equal to a sub 1 times, so 8 minus 1, it becomes 7. Then we have already a value of a sub 8. We substitute again. We have 1/48 is equal to a sub 1 times r raised to 7. So these are now considered equations. We have to solve these two equations simultaneously for a sub 1 and r. So let us divide the two given equations. We have 1/48 is equal to a sub 1 times r raised to 7 divided by 2/3 is equal to a sub 1 times r squared. So as we divide numbers, again, we have here complex fractions. We take the reciprocal of 2/3, it becomes 3/2, then multiply it by 1/48. And that will give us 1/32 is equal to, our a sub 1 here will be cancelled. And for the laws of exponent, we have to subtract the exponents. So we will have here r raised to 5. So we have to make our 1/32 a number with the same exponent on the other side. So we have to think of a number that would give us an exponent of 5. And that would be 1 over 2 raised to 5 is equal to r raised to 5. And we all know, as we distribute 5 both to the numerator and denominator, 1 to the 5th power would be 1, and 2 to the 5th power would be equal to 32. So again, we have 1 half raised to 5 is equal to r to the 5th power. So in this case, we disregard the exponents, and we will have here 1 half as the value of the common ratio. So we have already found the value of the common ratio. We have to find now the value of a sub 1. So using a sub 3, so again, our a sub 3 is equal to a sub 1 times r squared. We have a value of a sub 3 a while ago, that is 2/3, is equal to a sub 1 times the obtained value of r, which is 1 half. Let us substitute, squared. And then we simply simplify. So in this case, we will have 2/3 is equal to a sub 1. Then 1 half squared becomes 1 times 1 is 1. 2 times 2 is 1/4. So we have to eliminate 1/4 besides a sub 1 to get the value of a sub 1. So in doing that, we need to apply multiplication property of equality, or MPE. Let us multiply the whole equation by the reciprocal of 1/4, and that is positive 4. So it will be now cancelled, and then we simplify 2/3 times 4. That would be 8 over 3. So our a sub 1, in this case, using a sub 3, is equal to 8 over 3. Let's have another solution. Take note, we have another value which is given a while ago. That is a sub 8. So using a sub 8, our a sub 8 is equal to a sub 1 times r raised to 7. Our a sub 8 is equal to 1 over 48. Is equal to a sub 1 times, again, our obtained value of r is 1 half. Then raised to 7. Let us simplify this. 1 over 48 is equal to a sub 1 times 1 half raised to 7 power. That would give us 1 over 128. And the same process as what we have done a while ago, we apply the multiplication property of equality, or MPE, to eliminate 1 over 128 besides a sub 1, because we need to look for the first term. So multiply it by the reciprocal of 1 over 128, and that is 128. It will now be cancelled, and then 1 over 48 times 128 would be equal to 8 over 3. So our a sub 1 is also equal to 8 over 3. So either we use a sub 3 or a sub 8, we got 8 over 3. So we already found the value of d, which is, this is r. We found the value of r, which is 1 half, and a sub 1 is equal to 8 over 3. So we have to find now for the last one, the a sub 10, or the 10th term. So to find for a sub 10, we again use the formula in finding the n term of a geometric sequence. That is, a sub n is equal to a sub 1 times r raised to n minus 1. So we simply substitute the given values. So we have to find for a sub 10 is equal to the first term. 8 over 3 times our ratio is 1/2. So our ratio is raised to n. Our n is 10 minus 1. So let us simplify this first. So a sub 10 is equal to 8 over 3 times, so 10 minus 1 becomes 9. So we have a sub 10 is equal to 8 over 3, simplifying 1/2 over 9. So we will have 1 over 512. Then again, we multiply the fractions here. Our a sub 10 will be equal to 1 over 192. So our a sub 10 here is equal to 1 over 192. Okay, let us take another example. Which term of the geometric sequence 2, 8, 32, and so on is 33,554,432. So in this case, we need to find for the number of terms. So we're looking for the term number. So again, we use the formula a sub n is equal to a sub 1 times r raised to n minus 1. But since we're looking for n, we'll get another formula, a derived formula from this general formula. So our given there, our a sub 1 is equal to 2, and our r is equal to 4. And lastly, our a sub n is equal to 33,554,432. So first, we substitute the values. So using the first formula, we have a sub n is equal to a sub 1 times r raised to n minus 1. So by substitution, we place those values here. So we have 33,554,432 is equal to 2 times our r is 4 raised to n minus 1. So we still have, we don't have yet the value of n. So since we're going to find for the value of n, we have to eliminate first all the numbers beside this n. So first is 2. We multiply the whole equation by 1/2. So again, using the MPE. So it will now be cancelled, and then you will have this number, or the a sub n, multiplied by 1/2. And the answer would be 16,777,216 is equal to 4 raised to n minus 1. So the same thing as what we have done a while ago, we need to eliminate this 4. So we can do that by finding a number here, which is equivalent to the given number here, with the same base of 4. So in that case, we can have 4 raised to 12. So as we perform 4 raised to 12, this one is the same or equal to this. Equals 4 raised to n minus 1. So we disregard again the 4. So the remaining terms will be 12 equals n minus 1. So we have now here a linear equation. Again, 12 is equal to n minus 1. So to find for our n, we use the addition property of equality, or APE, to eliminate negative 1 besides n. So we add both sides positive 1. Therefore, we'll have n equals 12 plus 1, which is equal to 13. So in the first solution, using the general formula, we obtain that our n is equal to 13. Okay, let's have another solution. As we derive the formula from the general formula, let us observe if our n is really equal to 13. So we will now have the formula of n equals 1 plus the logarithm of a sub n over a sub 1 all over logarithm of r. So we substitute again the values. We have 1 plus logarithm of our a sub n, 33,554,432 over the first term, 2 all over the value of our r, logarithm of 4. So we need to use a calculator here to find the logarithm. So you can check that. Kindly get your calculator and then try to solve it also. So, simplifying the logarithm of this divided by logarithm of 4, that would give us 12. So again, you have n is equal to 1 plus 12 is also equal to 13. So we got the same value of n. Therefore, our 33,554,432 is the 13th term of the given sequence. Okay, what about geometric series? Geometric series is the indicated sum of the terms of a geometric sequence. So it can be a finite geometric series. So let us derive the formula in finding the finite geometric series. So let us have S sub n. Our S denotes sum of the terms. So be the sum of the first n terms of a geometric sequence. Then we will have S sub n is equal to our first term plus the second term plus the third term plus so other terms until the a sub n. So whatever number is that. So let us say this is the first equation. Or we can have S sub n is equal to a sub 1 plus, we all know that a sub 2 is obtained from having a sub 1 times r. Then our a sub 3 is obtained by having a sub 1 times r squared. Same thing with the other terms until we have a sub 1 times r raised to n minus 1. So this will be the second formula. So let us multiply the second equation by r. So we have S sub n is equal to a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus until we have a sub 1 times r raised to n minus 1. Multiply this by r, we'll get r times S sub n is equal to a sub 1 times r plus a sub 1 times r squared until we have here a sub 1 times r raised to n minus 1 plus a sub 1 times r raised to n. So this is now our third equation. So let us subtract our two given equations, the second and the third equation. So this one is our second equation without the r, and this is our third equation. So subtracting these equations, we have s sub n again is equal to a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus until we have a sub 1 times r raised to n minus 1. So we have to subtract this by r s sub n is equal to a sub 1 times r plus a sub 1 times r squared plus until we have a sub 1 times r raised to n minus 1 plus a sub 1 times r raised to n. So remember, in subtracting, our sign in our subtrahend, this is the minuend, the subtrahend, and the answer is difference. The sign here in the subtrahend will be changed. So in this case, these two will have s sub n minus r s sub n because they're different terms is equal to a sub 1. Then our a sub 1 times r here, we have 2 a sub 1 times r here, but this one becomes negative. So we change the sign. So it will now be cancelled. The same with a sub 1 r squared and a sub 1 times r raised to n minus 1. So the remaining here, this part would be a sub 1 times r raised to n. But remember, we change the sign. So instead of using positive or plus here, we use minus a sub 1 times r raised to n. So to continue that, we have s sub n minus r times s sub n is equal to a sub 1 minus a sub 1 times r raised to n. So we have to simplify this part by having the common factor, which is s sub n. We still have 1 minus r. S sub n times 1 is s sub n. S sub n times minus negative r is negative r s sub n. Is equal to a sub 1 minus a sub 1 times r raised to n. So we need to eliminate 1 minus r besides s sub n. So we apply multiplication property of equality. So multiply the whole equation by the reciprocal of 1 minus r. That is 1 over 1 minus r. So in this case, this one will be cancelled. We have s sub n is equal to a sub 1 minus a sub 1 times r raised to n over 1 minus r. So this formula can be used if the last term, if our last term or a sub n is not given. So as we have noticed, we have the sum of the terms, the first term, and of course we have here the common ratio. Or this one can still be simplified since we have a common factor. So we can have or s sub n is equal to a sub 1 times 1 minus r raised to n over 1 minus r. So if our a sub n is not given, we may choose between the two. For if what formula are we going to use? So if the last term is given, we need to find for another formula in finding the sum of the terms given geometric sequence. So again, we have s sub n is equal to a sub 1 minus a sub 1 times r raised to n over 1 minus r. Then we can simplify, or expand it rather, a sub 1 times r raised to n into a sub 1 times r raised to n minus 1 times r. So in this case, in r, we have here 1. So minus 1, negative 1, and 1, that will be cancelled. That's why it will still be equal to a sub 1 times r raised to n over 1 minus r. And we all know that this part is equal to A sub n. So we can substitute that. We have S sub n is equal to A sub 1 minus A sub n times R over 1 minus R. So in this case, this will be used in finding the sum of the terms given geometric sequence if our R is not equal to 1. Or we can use the following formula. So here are the different formulas to be used. So if we have repeating numbers, let's say 5, 5, 5, 5, 5, wherein our common ratio there is 1, we use this formula. S sub n is equal to the number of terms times the first term. And if our R is negative 1, let's say we have 5, negative 5, 5, negative 5, we have alternating signs, positive, negative, positive, negative. So that is why our R becomes negative 1. We may have two possible answers for the sum of the terms. So we use 0 if our n is even, and if our n is odd number, our sum of the terms would be 1. So let us have example. We have negative 9 plus 6 plus negative 4 plus until the 8th terms. So therefore, we have to find for the sum of the 8 terms, S sub 8. So in this case, our A sub 1 is negative 9. Our R will be 6 over negative 9, or that is simply negative 2/3. And since we're looking for S of 8, our N is equal to 8. Since A sub 1, R, and N are given here, we can use the formula S sub N is equal to A sub 1 times 1 minus R raised to N over 1 minus R. So as you have noticed, we have here the first term, the number of terms, and our common ratio. So by substitution, we have S sub 8 is equal to the first term, negative 9, times the quantity of 1 minus our R is negative 2/3 raised to N. So our N here is 8 over 1 minus negative 2/3. So let us simplify this equation. So we have here S of 8 is equal to negative 9 times the quantity of 1 minus, so our negative 2/3 to the 8th power will be equal to 256 over 6,561. All over, this one will be negative times negative becomes positive. So 1 plus 2/3. So to continue again, we have S of 8 is equal to negative 9 times the quantity of 1 minus 256 over 6,561 all over 1 plus 2/3. So in this case, yung 1 plus 2/3, it will be equal to, again, negative 9. Then we simplify 1 minus 256 over 6,561. over 1 plus 2/3. So we have here 6,305 over 6,561 all over 5/3. So we still have to multiply negative 9 by this fraction. So S of 8 is equal to negative 6,305 over 729 all over 5/3. So we can have a complex fractions again. We take the reciprocal of this 5/3, then multiply to the numerator. That would be negative 6,305 over 729 times 3/5. So that would be equal to negative 1,261 over 243. Aside from the finite geometric series, we also have what we call infinite geometric series. So to find the formula in solving infinite geometric series, let's say we have S of n is equal to a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed plus a sub 1 times r to the fourth power plus goes on. So we can have here a sub 1 plus, so we have here r times a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed plus and so on. So we can say that our a sub 1 plus r and this a sub 1 plus a sub 1 times r and so on is equal to this one, our sum. So we can substitute S or S of n. Solving the equation, S is equal to a sub 1 plus r times S. For our S, we can apply here the addition property of equality or the APE. We need to eliminate the RS here, so we have to add negative RS both sides. So you can have here S minus R times S is equal to a sub 1. And as you have noticed, we have common factor again here, which is S. So we can have 1 minus R times S is equal to a sub 1. Then to find for our S, we need to eliminate 1 minus R besides S by using multiplication property of equality or MPE. Multiply the whole equation again by the reciprocal of 1 minus R. And that is 1 over 1 minus R. So it will be cancelled. You will have S is equal to a sub 1 over 1 minus R. So let us have an example. We have 4 plus 2 plus 1 plus so on. So let us find the infinite series. So our given, we have a sub 1 is equal to 4. Our R will be 2 over 4, which is equal to 1 half. So by using our formula, we have a sub 1 over 1 minus r. By substitution, we will have 4 over 1 minus 1 half. Then let us simplify this. We'll have 4 over 1 minus 1 half is 1 half. Then again, we have a complex fraction here. That's why we have to take the reciprocal of the denominator. And then we multiply that to the numerator. So we have here 4 times 2 over 1, or simply 8. So therefore, the infinite series is 8.